Alright, so let's the fun begin. Because this is a complex algorithm, we broke in small parts and we completed a bunch of introductions so we would understand piece by piece how this works. We're going to do the same thing now that we are developing. Okay, so I want you to finish all those developing parts knowing how to create a suffix tree. So let's start by creating our package, which is going to be called Suffix Tree. So let's go to Search Main Java, Academy Learn Programming Algorithm, click in there, right click, New Package. Okay, and let's call it Suffix Tree, all lowercase. It should be highlighted, and you Ctrl+C that suffix tree, go to our Test Java Academy Learn Programming Algorithm, click in there, and paste our new package in there and just hit OK. So now we prepare for our unit test. We just create our package in there. Go back to our package under Search Main Java, click on that package and right click, New Class. Let's create a class called Suffix Tree. Let's create another class called Suffix Node. I could create internal classes, but I decide to create classes. And let's create a class called End. Okay. So what we are going to do now, do you remember, let's start by implementing something in our suffix node. Okay, so from our suffix node, you remember we had int start, right? We had a starting point, we had the end point, but the end was actually a global variable, right? So we are going to create the end in our suffix tree class, and this end will be carried over to our nodes, and once you change in here, all the nodes will change, unless that node has a end which is not pointing to the node we have in a suffix tree. Alright, so we're going to say end, and also remember we had index, right? Remember we have our node will have children, and because we are creating using array instead of using a map, these children will need to have a initial load in it, which will be 256. So every time you create a node, it's going to define 256 suffix nodes, and that suffix node, each one of the indexes will mean one character. So character 97 was A, 98 was B, and so on. So we are going to say suffix node children equals new suffix node, and in here usually we could do like just this, but instead let's create a final variable. Int total, this could even be static, 256, and here we call total. We actually can say max characters. I think it makes more sense, right? Copy that name, change in here. So now we have our children created. We have this defined in here. We have start and end index. There is something missing, correct? Which is our suffix link, right? So if this is a node that has a link to somewhere, this is going to tell us where. Okay. One more thing we are going to do here, we need to create a constructor. Suffix node, and this constructor will receive a start, int start, and end. Okay, and what we are going to do, this dot start equals start, and this dot end equals end, and that's it. So when someone creates this node, we know what's happening. One more thing we need to do, or we don't need to do, but we will do it because I want to have a visual representation of what's going on. I'm going to override because I don't toString method, and this toString method I'm going to use string builder, and we need to loop through the children, and I'm just going to print the children that doesn't have that's not null, right? Because I don't care about the null. So what I'm going to do is if children I, let me do a for loop first, right? Otherwise it doesn't work. Int I equals 0, I smaller than children.length, and I plus plus. So once I'm there, I can do this. If children I is not equals null, then print add actually to my string builder. I want to add the character. I want to add the character I'm at, right? So which character is that? Is the character I, which means on my suffix node 1, I have the character of 1 and so on. So on my suffix node 97, I have character of A, and that might have a children or not, right? So I'm going to print that. I'm just casting to character because int and character you can cast to each other, and it will be either the number or the actual character. And now I'm going to just print, and now is whatever we want in here, right? So let's say suffix node, and here we can say start equals actually we can also, I'm going to append suffix node start equals and s.toString, right? So we have start equals, and before I forget to close that, I'm going to close at the end, right? And what is the start? So now we are going to do s.append start, and I also want to append, just thinking through. So if we close this here, we print start, and now we can print all these strings. So we can do put this here, and let's do that. So actually we add this to the beginning, right? So we start our string like that, and then we add the characters if we want to. So we will see start 0, and then we'll see ABC, right? Or whatever that is. And I think this will give us a good hint of what's happening. Okay, so that's that. We also create the end, but we didn't implement the end, right? So the end actually is just going to store int end. Okay, and what I need to do here, I need to have a constructor that's going to say, hey, what is the end? Equals end. All right, so this is just a class, so we can have the reference in the memory. So when we use it, we just pass that reference in here instead of the value. Okay, so this is our node. So our node is done. our and is done. Let's also create the active point. So let's create a new Java class, active point. Okay. Remember, our active point had active node, active edge, and length. So suffix node, active node, active edge, and active length. Alright, and we will need to have a constructor in here which is going to receive active node, active edge. I'm not adding the types, I'm going to go back, and active length. Okay, and the types here is suffix node, int, and int. And now I'm going to say, hey, this dot active node equals active node, active edge, equals active length. So I just set them there, and that's it. What else I can do here is when you call this here passing the node, I'm going to say, hey, set the node as whatever you send to me, right? And remember the defaults, the active edge will be -1 and active length will be 0. Alright? And also we can override to a string and active point, and our active point will be, and here we are going to print active node. Right, so basically what I'm doing, I'm just printing some information so we can see what's going on when we say, hey, print that guy. Right, and the last one is length. Oops. Length plus active length. And then we close in here. Right, I can also use string builder here, but I won't do it. And done. So now we have our active point also implemented. So now our suffix tree, this will be very, very simple. We are going to, we need to set what is the unique character that we are going to create. So let's say final character unique equals, and in our case will be $, right? Private suffix node root, that will be our root. We will mess with our active point in here, right? And active point. Character, let's call this input, and it's actually an array. Int remaining, remember as we remaining, and this is our end. So this is all the global variables that we are going to use as we do stuff, as we build our suffix tree, right? And so just to finish, we are going to create a suffix tree constructor, and this constructor is just going to receive the array of characters, which will be our input. In our example, it was banana, right? And in here, we need to add, so let's say that someone sent banana, right? So they send banana. At the end, when we store in here for us to use, it needs to become banana dollar. Okay? So what I'm going to I'm going to say, hey, this dot input equals add unique input. Right? Of course, add unique doesn't exist, so we're going to create it. Public character add unique. I don't know why I'm adding T in there, but I keep doing this. Character input. So you receive the characters and it's going to return the characters plus the input. So what we need to do is I'm going to call this C, and this is say array equals new character, and I'm going to say input dot length. The size is fixed, so I cannot just add a dollar in here. I could down there in the code just add it, but I just want to get rid of it and just start it in here with the dollar already. So I'm going to use the length I have there plus 1, add to that C variable. Now I'm going to loop through. I could do a for each, but I will do the hard way. Right, so input dot length, because I just want to add the characters I have first. And what I'm going to do is Cx equals input x. So when I'm done with this, I have all the characters, and at the end, my C input dot length equals unique. So now I just added the last character in here. So let's just double check this. Input dot length will be 7. So if I'm adding C7, means that I'm correct. And then return C. So actually C goes to our input. And that's it for this video. So we create suffix tree, suffix node, active points, and end. Let's go to the next video and test it. And if you don't want to test, you just skip one video and we go straight to the next implementation. Thanks for watching.